Welcome back to geometry. We're at section or unit 6, circles. Today we have a lot of definitions, so if you need to hit the pause button, go ahead, hit the pause, and go ahead and fill out the following definitions. I'm going to go ahead and start. We have our first term is a circle, and we're told that the circle is a set of all points that are equidistant to a fixed point called the center. So here's our center point O. Around this center point O, there's an infinite amount of points that can go all the way around this center point, and they're the same distance. All these points are exactly the same distance to our center point O. And so that's how we form a circle. Alright, and if I were to draw a line out to any of these points, and I were to do this, I could do this as many times as I want, but one of these is called a radius, okay, and then all three of these would become a radii. So radii becomes plural for radius, but these are all going to have the same length, and we can use the radius to find circumference, which is 2 pi r. We can also use the radius to find the area, which is pi r squared, and we'll get into all that later. It's also true that circles that are congruent have congruent radii, meaning I draw one circle and it has a radius of say 4. I draw a second circle, and this time I'll have my radius going down to say 6 o'clock, and it's still 4. Well, since these circles have the same radius, then they are each congruent, and so they are congruent circles. All circles, depending on their size, are similar. They're all similar. Next, we have concentric circles, and so that would be the case where we're going to draw a circle within a circle. And if I draw a circle within a circle, that would look like, let's do that up here. So we have one circle with the same center point and a second circle with the same center point. And so those are concentric circles. A diameter is a chord that contains the center. So chord is a new term, which we'll define chord in a second, but if we're going to draw a circle and we draw one radius at 12 o'clock, we draw a second radius at 6 o'clock, this creates a straight line, and so we could say this is point A and point B, and therefore AB is our diameter in this circle. Next we have a chord. A chord isn't in your notes, but it should be, so let's define what a chord is. A chord has two endpoints on a circle. So we could say this, here's point A and point B, this is chord AB. Alright, so there's chord AB. I could put point C here and point D there, and then again it has two endpoints on a circle, and so there's chord CD. Alright, and then the case where it contains the center point and it has two endpoints, that's going to be a diameter. Next big term we have is a central angle. So a central angle is an angle whose vertex is at the center. So let me change colors here. If I was going to draw this angle right here, let's call this angle 1. Okay, angle 1 is a central angle because it's formed at the center. Okay, and what's nice to know about central angles is, let's say that this angle was 40 degrees. Okay, well, if this angle is 40 degrees, then the measure of this arc is also going to be 40 degrees, and we'll get into that in just a second as well. So that leads us next into our term with arc, and again arc, let's change colors again. Arc, I could say, is from AB, is from DC, so this is part of a circle. This is part of our circle right here, AB and CD. Alright, let's label this circle. We're going to call this point P in the middle. We have point A on the outside, and then we're going to form a diameter with C. So we'll try and draw this line as straight as we can. Not that straight. And then let's put point B up here, and then we'll put point D down below. Alright, so a semicircle is an arc that is half the size of a circle. So if I look at our drawing here, and in parentheses, please put 2 or 3. And what 2 or 3 means is that you can use 2 or 3 letters to define or label a semicircle. So when I look, AC is supposed to be our diameter. So AC is certainly a semicircle, okay? Or you could call it CA. You could go either way. Or you can use 3 letters, and you can say that this is semicircle ADC, okay? Or you could say semicircle ABC. So again, you can use 2 or 3. Minor arcs, same thing. We can use 2 or 3 letters to define a minor arc. What we have to remember is that it's smaller than a semicircle, alright? So it's less than 180 degrees. So when I look at this drawing, I see that I have minor arc AB, I have minor arc BC, I have minor arc CD, I have minor arc DA. One thing that we can't use is, we can't use point P because point P is our center point. And so when we define arcs, arcs are part of a circle. We will never use our center point. Alright, for the major arc, we always use 3 only. We can't use 2 letters. So, and this is going to be greater than 180 degrees. So for the major arc, I could say major arc ACD. I could say major arc DBC. I could say major arc CDB, and there's more. Alright, next we have adjacent arcs. Just like we had adjacent angles, we can have 2 arcs that are side by side. So looking at our drawing, we have DA, arc DA, and arc AB are adjacent arcs. We could say arc AB and BC, and there's many more that we can list. Alright, next drawing, please put point X here. We're going to place point Y here. Point Q is our center. Point W goes down here. We're going to draw a diameter. And then point Z will go down below. Alright, label the following circle. Name 3 minor arcs. So that's the easy part, X, Y. And remember that on minor arcs, we can name 3 letters. So I could actually say this is arc X, or this is minor arc X, Y, Z. Okay? But just know that arc X, Y, Z is congruent to X, Z. It's the same minor arc. Alright? Just like back up here where we said that semicircle could be AC or CA. We also said that we had semicircle ADC. So, you know, it just, there's more than one way that we can show semicircles, minor arcs, and major arcs. Alright, more minor arcs. We have YZ minor arc. We have WZ minor arc. Alright, major arcs. This time we're going to use 3 letters. We can use X, Y, W. We can use W, Y, Z. And we could use Y, W, X. Alright, now one other thing too is that when we look at major arcs and minor arcs, we need to look at the starting point and end point. So let's take a look at this last one that I did with major arc YWX. We started at W and ended at X. Okay, so my question to you is, if I were to name major arc Y, Z, X, are these major arcs each congruent? That's my question to you. Are they congruent? The answer to that is yes. And why is it yes? Because they have the same starting point and the same ending point. Semicircles, we have YW, or we could call it WY. I could also use 3. I could say WZY is a semicircle. I could say YXW is a semicircle. 2 adjacent arcs, XY and YZ. And let's go with ZW and WX. Alright, a long time ago with our segment addition postulate, we would start off with the segment, say A and B, and then we had point C. And we could say that segment AB plus segment BC is equal to segment AC. We can do the same thing with arcs. Alright, so for arcs, we have 2 adjacent arcs. And so from our problem, I can say that arc XY plus arc YZ is going to equal arc XZ. Alright, next problem. Find the measure of the angles and the arcs of circle O. So the first thing that we want to look for are central angles. This is going to be huge. These are our friends because it makes the problem much easier. 56 degrees is a central angle. Therefore, I can say that the measure of dx is going to be 56 degrees. We can also do its converse. We have 40 degrees on the outside. That means this central angle is at 40 degrees. Why are these two angles central angles? Because they're formed with our center point O. We can also use the rules of a straight line. We have 180 degrees in all straight lines. So this diameter right here, if we have 40, 56, subtract that from 180, we end up with an 84 degree angle, which means XW has to be 84 degrees. Alright, so measure of arc dx was 56 degrees. They want to know the measure of YXW, that's 180 degrees. Measure of WOX, that's going to be 84 degrees. Measure of MDW. Alright, the other rule that we can use here are vertical angles. So if we look at this straight line and this straight line in blue, let's make it green, we see that 84 and 84, these are vertical angles. So we would add up 180 degrees for our semicircle, add that to 84, and we get 264 degrees. Measure of angle MOW, if we have 180 here and 84 of it is used up, this becomes a 96 degree angle. And measure of YX is going to be 40 plus 56, 96 degrees. Alright, we're back to circumference. So when we think of circumference, it's actually the distance around a circle. Now, it's hard for us to imagine this or that, but what we're really saying is that if we had a piece of yarn, let's say that our yarn was flat, okay? So here's our piece of yarn. If we were to curl this yarn into a ball and create a perfect circle, it would look like this. Now the circumference is going to be the length of this yarn. So how long is this piece of string? That's our circumference. Now the formula for that is going to read C is equal to 2 pi r. And then it's also can be shown as C is equal to pi times d. Now, are these the same formula? Yes, they are. Remember that one diameter is equal to 2 radii. So that's why we have c is equal to 2 pi r and c is equal to pi times d. All right, for the arc length, this is much more challenging in a sense. The arc length, let's go back to our circle that we created. And let's say that we have, point A here and point B there. Well, the arc length is going to be this little piece in red right here. So how long is this piece? Well, let's do some math. Let's say that we created this radius. It creates a 90-degree angle. And so this is a 90-degree angle here. All right? What that now means is that from that 90-degree angle, if we were to say that the radius was 4, let's say we use 4 and 4, okay? So we would say that c is equal to 2 pi multiplied by 4. We would say that c is equal to 8 pi. So that would be the total length of this piece of yarn that we have. But remember that when we find the arc length, we only want to find this piece. So how long is this piece from A to B, this little piece right here? Well, it's not 8 pi, but since this is a 90-degree angle, there are 4 90-degree angles in all circles, right? And so this would be considered 1/4 of the total circle. So this arc length in this problem we could say is 1/4 times 8 pi, which would give us 2 pi. All right, now we have a formula for this. Arc length we usually call x, it's unknown. We're going to say that it's equal to the arc of AB, which in our case was 90 degrees, divided by 360 degrees. Okay, and so where are we pulling 360 degrees? Well, do you recall that in a triangle, all triangles have 180 degrees? Do you recall that in all quadrilaterals, they have 360 degrees? And in a pentagon, we have 540 degrees. So in a circle, if we think about a circle, let's draw a graph. Okay, and so there's our graph, and then let's say that in Q1, this is a 90-degree angle, 90 degrees, 90 degrees, and 90 degrees here. So we have a window of 90-degree angles. Well, we can draw a circle that would encompass all of this, and we add up 99 to get 360. All circles have 360 degrees in it. So it's no surprise that we take part of our arc divided by 360, and then we have to multiply this by 2 pi r, which is our circumference. All right, next, sorry about that. In this problem, we're told that the circumference, or we're told that the circle has a radius of 6. So this would be 6, 6, 6, and 6, and 6. We have 5 radii in the circle. They're all 6. All right, exact answers. When we give in exact answer, it'll be left in terms of pi. So we would say c is equal to 2 pi times 6, which means c is equal to 12 pi. And that's our exact answer. When we use approximate, we plug in 3.14 for pi, so we would say c is equal to 2 times 3.14 times 6, and that would give us a grand total of 37.7 feet. Okay, and that would be an approximate answer because we used 3.14 for pi. All right, find the exact lengths in the following arcs given that AB is congruent and equal to BD. All right, well, this is a huge piece of information. This is huge, and without it, we wouldn't be able to solve this problem. So they're saying that AB is congruent and equal to BD. Well, what that means is that both of their central angles are the same, and since this is 90 degrees and we have a straight line, that means this has to be a 45-degree angle and a 45-degree angle. So we want to put 45 degrees here and 45 degrees here. It's always smart to mark these up as you see it, so it helps you answer these questions. All right, the other big thing here is we have an M in front. Whenever we have an M in front of the arc, that means the measure, your answer is always going to be in degrees. So measure of arc AD is going to be a 90-degree angle. Measure of arc AE is going to be 90 plus 90, that's 180 degrees, our semicircle. And then measure of arc ADF, it goes all the way around. Now, again, we have to use the properties of vertical angles here. So highlight this diameter, or this line, highlight this diameter, or this line, and we see that these two angles are vertical angles. So this angle has to be 45 degrees. It's a central angle, so this arc is also going to be 45 degrees. So we add all those up. 180 plus 45 would give me 225 degrees. All right, next we have the measure of arc AD. Now, before we use this formula, because we can plug this in. I mean, we can plug everything in. So the arc of AB over 360 times 2 pi r. But let's solve this without doing that first. It's always nice to know how to solve the problem without formulas. Formulas are a shortcut, and we can use those when we understand how to do the problem. There's no m here, so they actually want the length of AD. So let's highlight this. They want the length of this. Okay. Luckily for us, we have a 90-degree angle. So the circumference of the total circle is going to be 2 pi times 6, which gives me 12 pi. And I'm looking at 1/4 because I have 90 degrees. So I just have to multiply this by 1/4, and that's how we get 3 pi. All right, now if you're a formula person and you love using formulas, enter in the measure of arc AB, which was 90. 90 over 360 times 2 pi r, which was 12 pi. You reduce 90 over 360, you get 1/4. 1/4 times 12 pi is 3 pi. All right, next we have AE. AE is a semicircle, which is half of a circle. So again, we have a 12 pi circumference, and AE is going to cover half, so we take half, and that gives me 6 pi. Again, we could have easily plugged in 180 over 360 times 2 pi r, and that would give us 6 pi. All right, ADF, we have 180 plus 45. In this problem, we actually should use our formula. So we have a 200, we're going to say x is the length, 225-degree angle over 360 degrees times 2 pi r, which was 12 pi. And when we enter that in, we get 15 pi. All right, let's move down below. They want us to find the measure and the length of each arc. We have a term here that says the congruent arcs. For right now, they have the same measure and length. They have the same measure and length. All right, here's our center point A with a radius of 10. And PQ has a central angle of 60 degrees. All right, this should be arc. It's not in your notes. This should be a center point. So let's put P here. We'll put Q there. And let's draw this out. And so they're saying that this angle here is a 60-degree angle. We would know that this length is also 10, and so we can put 60 degrees here. So to answer A, the measure of the arc, we can say that PQ is 60 degrees. And I should have put an M here. It's the measure. All right, B asked for the length of PQ, so there's no M, it's just PQ. And so the length of PQ is going to be 60 over 360 times 2 pi r, which that's going to be 10. So we get 1/6 times 20 pi, which gives me 10/3 pi centimeters is my answer. All right, down over here we have center point B, radius of 3, central angle 120. We'll open it up. This is also going to be 3. They want us to use X and Y. So we have 120 degrees. That means the measure of XY is going to be 120 degrees. Now the length, for the length of xy, we're going to take our 120 degree angle, divide it by 360, multiply it by 2 pi times 3, and so we get 1/3 times 6 pi, which gives me 2 pi. That's our length. Alright, for our last problem, we're actually going to do this problem in class, so see me in class and I will show you. Thanks for joining us. See you next time.